Hello there and welcome to the video. In this video we are going to look at finding the gradient and the y-intercept from the equation of a straight line. So I'm going to present you with some equations of linear graphs, and using your understanding of y equals mx plus c, we're going to find the gradient and the y-intercept, and then we look at seeing how can we relate that to the actual graph. What would the actual graph look like once we know the gradient and the y-intercept? Okay, so first of all, let's focus on this red box at the top of the screen. This is the form that all equations of straight line graphs may take. Okay, so if we have an equation of a straight line in this order, in this setup, y equals mx plus c, then we can state that the gradient is the number in front of the x, the coefficient of x, which we often refer to as m. And then the number that comes here in where the c value is would be our y-intercept. This is sometimes called the constant. And whatever number is here, whether it's positive or negative, that's going to tell us where the linear graph would cross the y-axis, the y-intercept. The bit that's vitally important about this setup here is that this y must be singular. It must be one y. So when we're given a question and we're not already dealing with one y equals, then we may need to manipulate some algebra, change some things around, rearrange things slightly so it is in this order. Once it's in this order, then we can go ahead and state the gradient and the y-intercept. Okay, so if I have a look at my first question, here is the equation of a linear graph. 3y equals 6x minus 12. And I want to find its gradient and its y-intercept. A very common misconception, a common error, is to state that the gradient is 6 and the y-intercept is negative 12. I see a lot of students do that when they first encounter this topic. However, this equation of the straight line is not yet in the correct form. We want it in this form when we're just dealing with one y. We're currently dealing with three y's. So I'm just going to manipulate this bit of algebra slightly. I'm going to divide everything by 3, because that will divide the 3y by 3, which will leave me with a singular y. So I'm going to divide everything by 3 to be left with y equals 2x minus 4. Once that is done, y equals 2x minus 4. Now it's a lot easier to select my gradient, which is this number here, the coefficient of x, the number in front of the x. That is my gradient. And remember, we represent gradient with an m. And my y-intercept is negative 4. And remember, we represent the y-intercept with the constant c. So at first glance, you may have thought I was dealing with a gradient of 6 and a y-intercept of minus 12, but that was not in the correct order, not in the order I want to deal with. I wanted it in this order when I'm dealing with a singular y, which is why I ended up here. Then I was able to pull out my gradient and my y-intercept. Okay, let's have a look at another question. Again, this is what I'm aiming for. I'm aiming to have my equation of the straight line in this order, in this form. At the minute, it is not in the correct order. It is not in the correct form. To start with, I've got two y's, but also my x is on the wrong side of the equal sign. I want the x to move from here to here. So I need to do two things to manipulate this bit of algebra. I'm going to divide by 2 to be left with y plus 4x equals 10. but then my plus 4x I will take away from this side and at the same time subtract from this side. So what I'm going to be left with is y equals minus 4x plus 10. I divided by 2 and then I took my plus 4x, because once it was divided by 2 it was a 4, and I moved it to the other side, which is the same as subtracting 4x and subtracting 4x. Now if we look at my equation of my linear graph, you can see that my m value, the gradient, is minus 4, the coefficient of x, and my constant, the y-intercept, is positive 10. So I can confidently state that I'm dealing with a gradient of minus 4 and a y-intercept of 10. Okay, let's have a look at another example. Again, this is what I'm aiming for. I'm aiming to manipulate my equation of the straight line into this form. I want to be dealing with a single y, and I would like my x term and my constant on this side of the equal sign. Y equals mx plus c. So if I look at this equation of a linear graph, I need to do some manipulation. First of all, I'm dealing with 5 y's, and I want to be dealing with 1 y, and my x term and my constant term are on the incorrect side of the equal sign. I want both of these terms over here. So what I would do is I would manipulate this equation. I'm going to divide by 5, so I'm going to be left with y plus 2x minus 1 equals 0. So that means I'm dealing with 1y. Then I'm going to take this plus 2x, I'm going to subtract 2x from this side, and at the same time subtracting 2x from this side. I'm going to add 1 to this side, at the same time I'm going to add 1 to this side. Remember, I'm talking about a 2x and a 1 because I'm talking about after I've divided everything by 5. So once I do that manipulation, I'll be left with this, which now is in the correct form. Y equals mx plus c, when m, my gradient, is minus 2, and c, my y-intercept, is positive 1. So once I've done that rearrangement, done that manipulation, then I can confidently state that the gradient is minus 2 and the y-intercept is 1. So if I went ahead and drew the graph, I would know that the linear line, the straight line, cuts through number 1 on the y-axis, and it has a gradient of negative 2. So for every 1 square along, I would be coming 2 squares down. That would relate to a gradient of negative 2. Okay, so here's some questions for you to have a go. For each of these questions, I would just like you to pause the video, show me a little bit of working out how you would manipulate the algebra, how you would rearrange the algebra to find both the gradient, the m value, and the y-intercept, the c value. Once you've found the gradient and the y-intercept, I would like you to have a little think, or maybe sketch, what you think the graph of this equation would look like. And then I'll show you that when I talk through my solution. Could you pause the video now, please? Okay, welcome back. So I'll just show you my answer. So what we have here is 2y equals 4x plus 8. So we're in the correct order, y equals mx plus c. However, we are not dealing with a singular y. So what we need to do here is divide everything by 2 to be left with y equals 2x plus 4. So that's telling me my gradient is positive 2 and my y-intercept is 4. So those should be your two answers. So then if we took these values, gradient of 2, y-intercept of 4, and had a little think about the graph of 2y equals 4x plus 8, this is what the graph would look like. And you should be able to sketch this graph from these two bits of information. First of all, we know this point. It's got to be 4. The y-intercept is 4. We're dealing with a positive gradient, so we're expecting the line to go uphill, and it's a gradient of 2. So if I pick a point on the graph and go 1 square along, you'll see I'm going 2 squares up. If I pick this point on the graph, 1 square along, I go 2 squares up. So that's telling me that line has a gradient of 2. So from those two bits of information, you should be able to plot or sketch the linear graph. Okay, here's another question for you to have a go at. Again, could you pause the video? Could you manipulate the algebra to tell me the gradient and the y-intercept? And could you also have a little think about what the graph of this equation would look like? Could you pause the video now? Okay, welcome back. So this time we are not in the correct order. This minus 9x needs to be on the opposite side, but we're also dealing with too many y's. So everything needs to be divided by 3. So if we were to go ahead and divide everything by 3, then we would be left with a minus 3x here. So we would add 3x to this side, at the same time adding 3x to this side. So this would be the equation you're left with. Now it's in the correct order. Y equals mx plus c, with m being 3, there's my gradient, and c being 4, there's my y-intercept. If I wanted to relate this to the graph of the equation, it would look like this. From these two bits of information, there's my y-intercept at 4. And if I picked a point on the graph, let's start here, and went 1 square along, I would have to go 3 squares up before I met the graph again. If I was to start on this point, 1 square along, 3 squares up. So from these two bits of information, I can have a good go at plotting or sketching the linear graph. Okay, could you do the same for this question? Could you pause the video and find the gradient and y-intercept and have a go at sketching the graph? Okay, welcome back. This is what your answer should look like. I'm dealing with two y's, so I want everything divided by 2. And then my plus 5x would be on the wrong side. So I'm going to subtract 5x from this side, at the same time subtracting 5x from this side. Now I'm left with y equals mx plus c, with m being minus 5 and c being 2. So if I wanted to relate that to the graph, my y-intercept is now at 2. And I'm dealing with a negative gradient, so I'm expecting my linear graph to go downhill, and my gradient is negative 5. So if I pick a point on the graph and go 1 square along, you'll see that I go 5 squares down before I rejoin the line. So those two bits of information help me produce the graph of the equation 2y plus 10x equals 4. Okay, could you do the same again? Could you pause the video here, please, and find the gradient and y-intercept and have a go at also sketching the graph? Okay, welcome back. This is what your answer should look like. We're dealing with two y's, so we're going to divide everything by 2. That's going to leave us with 3.5 as the coefficient of x, 3.5. Then we need to put it in the order y equals mx plus c. So once I've divided by 2, my 3.5x and my 4, we just put them in the correct order. Nothing is going over the equal sign, which is why we haven't changed any signs here. That's why they both remain positive. because they're both on the correct side of the equal sign. So it still technically reads correct, but we just want to be consistent and have it in the order y equals mx plus c. With m being 3.5, so I'm dealing with a gradient of 3.5 and a y-intercept of 4. My graph would look like this. Y-intercept is at 4, and if I pick a point on the graph, let's go with this point here, 1 along, I would go 3.5 squares up before I rejoined the linear graph. And that graph there is a representation of 2y equals 8 plus 7x. Very well done if you were able to draw that graph. Okay, last one for you to have a go at. Again, could you please pause the video at this point, work through finding the gradient, the y-intercept, and also have a go at sketching the graph. Okay, welcome back. So your answer should look like this. I'm dealing with 4y's, so everything is going to get divided by 4, which is going to leave me with 1/4 here, which is 0.25 or minus 0.25 at this position. And then my x term and my constant are both on the wrong side of the equal sign, so they will need to be rearranged and manipulated to make sure they're in the correct order. So what I'm left with is y equals minus x plus 1/4 plus 0.25. So my gradient is -1. Remember, in algebra, when there's nothing in front of the letter, we assume it's a 1. And my y-intercept is 1/4, 0.25. If I wanted to relate that to the graph, it would look like this. My y-intercept is here at 0.25. I'm dealing with a negative gradient, so my line's coming downhill. And if I was to pick a point on the graph, let's have a look. If I was to pick a point on the graph, we will start here. And if I went 1 along, I would go 1 down before I rejoined the graph. So it doesn't look like we go through the exact coordinates on this graph due to the fact our y-intercept is 0.25. But I can assure you, any point you pick on the graph, if you go 1 full square along and 1 full square down, then of course you're dealing with the gradient of -1. Okay, so now it's your turn to have a go at a few tasks. The first task is on the screen. You can see I've put 6 equations of straight line graphs on the left-hand side of the screen, and I've put 6 pairs of gradients and y-intercepts on the right side of the screen. What your task is to show me your working out and show me how you found the gradient and y-intercept of each graph and match up to the correct gradient and y-intercept. However, one of the equations does not match up. So I would like you to highlight that equation as the odd one out. Okay, could you pause the video and have a go at this task now? Okay, welcome back. Let's have a little look at my matchings. So this should look something like this. So if I talk through the first question here, we've got 2y plus 6x equals 18, and we need to manipulate it into the order y equals mx plus c. So I'm going to divide by 2, and then I'm going to take the plus 3x and subtract it from both sides. So I'm left with y equals minus 3x plus 9. That will match up with a gradient of -3 and a y-intercept of 9. If we look for the odd one out here, you can see when I manipulate this bit of algebra, I need to divide by 5, but I also need to take my plus 1, subtract it from this side, and subtract it from this side. So my constant will be -1, not the positive 1 that is displayed in this possible answer. So hopefully you've highlighted these two as your odd one out. Very well done if you were able to match up those correct answers. Okay, so here is your next task. I've put on the screen 16 questions, 16 equations of linear graphs. For each of the equations, I just want us to practice our algebra skills, practice our rearrangement skills. And for each one, I would like you to rearrange into the form y equals mx plus c. And then I would like you to state the gradient of each linear graph. So for all 16, could you show me some working out and find the m value, the gradient? Could you pause the video now, please? Okay, welcome back. And this is what my answers look like. So for each of the questions, you should have shown me a little bit of manipulation, a little bit of algebra work in order to reach your m value, your gradient value. You can see from the first question that no manipulation was needed. We are already in the form y equals mx plus 3, or minus 3 in this case. So your gradient is 2. With the second question, we're dealing with two y's, so everything should be getting divided by 2, which means I'm going to be dealing with a coefficient of 3. I'm going to be dealing with 3x, so my gradient would be 3. You can go ahead and work through your other solutions. Let's have a quick look at this question as well. 0.5y. So this time we're not going to divide the equation, but rather we're going to multiply everything by 2, because 0.5 is a half. A half times 2 would give me that 1y, which is what I'm aiming for, which is why I end up with minus 6x plus 4, so minus 6 being my gradient. Again, down here, we've got a similar sort of question where we're dealing with a quarter, 0.25. So everything in the equation would have to be multiplied by 4 to bring this to 1y. So I'd be dealing with minus 28x. So I'd have to add 28x to this side, as well as adding 28x to this side, giving me a gradient of 28. A very steep graph indeed. Okay, so the last task for you to have a go at is just a consolidation task, which hopefully tests our understanding of today's lesson. So for each of the questions, could you answer the question that is given, showing some working out and showing your full understanding of gradient and y-intercept? Could you pause the video now, have a go at all 8 questions, and then I'll show you my solutions when you unpause the video. Okay, welcome back. My solutions look like this. So for each equation, you can see that some manipulation was needed, some working out was needed, and then you were able to confidently state your gradient and y-intercept. If we just look at this one briefly, y equals 4x. Remember, that could be wrote as y equals 4x plus 0. So that's telling me the y-intercept is through the origin. So my y-intercept is at 0. A couple of questions like this also. When we're dividing by 3, because we want to be dealing with 1y, 4 divided by 3, in this case it's best to leave your answer as a fraction. That would give me positive 4/3, which I would then have to subtract from each side to get a gradient of minus 4/3. So sometimes the manipulation, it's easier to leave things in fractions because they're a little bit easier to calculate with. You can see that's happened over here as well. Okay, take a little bit of time to mark up and assess your answers, just making sure you've got a good understanding of the topic. Very well done if you were able to get all 8 right. You've shown a good understanding of finding the gradient and y-intercept from the equation of a straight line graph. Well done.